Here's question 1. Now here we've got to find the gradient, so we need to differentiate. Multiply by your power, reduce the power by 1. We're given information where x equals a half, so put half into that equation, work it out. Yes, achieved. For this one here, we want to have we're given the gradient function, so we want the actual function. So just write out the gradient function and go through add 1 to the power, divide by the new power. Do the same for the next term, add your constant. Tidy that up a bit. Now it passes through the point 214, so we can work out what C is by calculating and using the 214. C is 2. Don't forget to finish it off by rewriting your equation with the 2 instead of the C. Here we're given the velocity and we want the distance. So we take the velocity equation, we add 1 to the power, divide by the new power, and add a constant. Now in this game, you're going to start and you're going to bowl the curling stone or whatever it is. C would equal 0 because the time is 0. So we can get rid of the C. Now we want to find out when it stops. It stops when there's no velocity. When it's not going anywhere, velocity is 0. That's at 10 seconds. So put 10 into the equation and you have 50 meters for merit. Here we want to find the equation of the tangent. The equation of the tangent is y equals mx plus c. We need to find the gradient, so we're going to have to differentiate. Multiply by the power, reduce the power by 1. Put 2 into the equation, and we find that the gradient is 8. Now that's the gradient of the equation. Use the points 2 and 9. 9 equals 8 times 2 plus c. c equals negative 7. Write out the gradient again, and you have another merit. For this one here, we have a curve. We're talking about the tangent. So we're going to have to differentiate. Multiply by the power, reduce the power by 1. We're told that the tangent has that equation. Rearrange it to get it in y equals negative x over 2 minus 6. What's the gradient of that? The gradient is negative a half. We have a gradient function, f dash x, so we put negative a half equals that gradient function. Change side, change sign. We find that x equals the square root of 1, which is plus or minus 1. So there are two answers. And we have to find the y value for that. So we put it in the equation which I've circled up there, and we get two values for the y. Negative 1, negative 5.5, and 1, negative 8.5. One of those is the tangent to the curve. The other one is the tangent to the other curve. So let's check in this equation which one is correct. So you test and you find that negative 1 and negative 5.5 makes that equation correct. 1, negative 8.5 doesn't work, so the correct coordinate is negative 1, negative 5.5. For this one here, we're asked how many kilometers. So that's a distance. We're given the velocity. So let's take the velocity for Catherine's car, and we're going to add 1 to the power and divide by the new power and add a constant. Now because we're starting at time is 0, because she's leaving the pits, so that's when time starts, so the constant will equal 0. So we can remove the constant, tidy up the equation, do the same for Doug's velocity, and we add 1 to the power, divide by the new power, tidy it up. Now when does Catherine pass Doug? That means the distance between them will be 0. So we make those two equal, and we subtract one from the other. You factorize. You can find your two solutions are 0 and 5 over 19 or 10 over 38, or you could write it as a decimal. Now that's the time. We are asked for the distance. So we take the distance for Catherine's car, put the 5 over 19 in it, and we find that it's 49.5 kilometers. If you put the distance in Doug's equation for distance, it'd also be 49.45 kilometres to 2 decimal places. And that's excellent. So we've just raced through that question and done it. Cool.